Hey everyone, it is very important to always read the lesson summary. Lesson summary gives you the good vocabulary that you're using and what you're talking about, the main concept. But it's great to write this stuff down in a journal, to highlight, to keep a notebook of just the vocabulary words, things you're going to want to know. So if you remember, a variable is like a letter, that represents a missing amount. So A could be a variable, X can be a variable if it's not used as multiplication, right? Y in any letter, but it can also just be a placeholder, something that can hold for a number we don't know that can be plugged in later. All right, an expression is what we use in algebra when we are trying to explain maybe a situation, a numeric situation, where sometimes we'll have numbers, sometimes we'll have letters, but we're just trying to say that Johnny had a certain number of apples, right? Oh, that's the wrong thing there. He had a certain number of apples, and he's going to get a few more apples. So A plus B, right? Or I could do uh, Sammy got $15 for his birthday, but then he bought some candy, right? So we don't know how much he spent on the candy, so I'm going to use X, but we know he had $15. Bottom line is, it can have numbers and letters, but what don't you see? What don't you see that you usually see in something that you're trying to solve? Okay, an equal sign. You don't see the equal sign, all right? That's part of an equation. An equation has an equal sign in it, and so an equation has a statement of equality, you could say. And what we're going to do is say that, okay, well, A plus B equals C. Now I've made it an equation because I'm trying to solve it, because I have this statement of equality. Or if I were to say, all right, let's go back to the 15x one, 15 minus x. If I were to say that it was 15 minus x equals 7, then I can say that x equals 8. And so that makes it an equation. This is an equation. And so I know this all says really confusing things, but hopefully that explanation helps you when we have numbers and letters together that we're using to find things or to explain something, but we don't have an equal sign, we have an expression. When we have a statement of equality, when we say that it equals something and therefore we could solve it, or at least try to solve it, then we have an equation. That's really the big difference there. All right, let's move on to the problem set. Okay, so before we go over the problem sets, remember, pause the video, try and do these. Make sure you're doing these on your own. Hopefully you're just watching this because you already finished them and you're just checking. But as I go over these, remember, it does nobody any good for you to just write down what I write down and say, hey, look what I did. Make sure you're doing thinking on your own, trying it. If you're completely unsure, you've tried a couple things, then see what I did and try to figure out why and how I did it and make it make sense to you. But pause the video before and after questions if you need to make sure that you are doing thinking on your own and just using this as a self-assessment. Okay. Also, I do want to notice that it does say equation here, and what do you see in the problems? You see your equal sign because you see the word equality in there. So equal sign for equations, right? So again, I'm going to go ahead and jump in. Number one, 4 to the third power equals y, so we're looking for the value of y. And 4 to the third power means 4 times 4 times 4, which is you work out, you get 16 times 4, which is 64. Number 2, we have 8a equals 24. If you remember, that means 8 times a, right? So I might have 8 times a over here. And then I'm going to draw it in my model up here. 24 is my whole, and it's going to break up into my 8 times a is my parts. That helps me know because since 24 is my whole, and I'm looking for a part, I can use the opposite of multiplication and do 24 divided by the value I have, which is 8, and that will give me a. I can also do the equation balance system, which means I want to get a by itself, so I need to get rid of this 8 that's touching the a. which since it's times 8, I need to do the opposite of times 8 to cancel it out, which is divided by 8. And that cancels out my 8's. But I also have to do divided by 8 over here because I have to keep my equation perfectly balanced. So I have to do the same on both sides. And once again, you see to find a, then I have 24 divided by 8. So therefore, a equals 3. Next question is 32 equals g minus 4. Now this one's not trying to trick you, but you need to pay attention to how it's written. My equal sign is here. So that means the value of 32 is the same as the value of g minus 4. And since this is subtraction, g comes first in the subtraction part of the problem, and therefore g is my whole. So I would have g up here, and then I'd have my 32, and I'd have my 4. So if that's the case, what would I do with 32 and 4 to find g? I would add them. So g has to equal 36. And then I can plug it in and check, but this always works. If you understand part-whole relationships, this always works. 36 minus 4 equals 32. Yes, it does. Now I feel good. Next question is 56 equals j plus 29. Again, they put the the answer over here and then the value of the problem on this side. But either way, it's still j plus 29 equals 56. You can read it however you want. And in this case, we've got 56 as our total because it's all by itself on a plus problem. When 29 is one of its parts and the other part is j. We don't know. So what would I do to figure out my missing part using 56 and 29? I always want to use the numbers that I have. Right, I would subtract them. So subtracting 56 and 29 will give me my answer, which is going to be 27. So j equals 27. But I could also do my balance, if you guys like that, right? It's perfectly balanced right now, but the j is not by itself. So to make j by itself, I have to get rid of this plus 29. To get rid of plus 29, I do its opposite, which is minus 29. But I also have to do minus 29 on this side. And again, you see, I'm going to end up with 56 minus 29 is my problem. I just like understanding part-whole relationships because it lets me skip straight to the problem that I'm going to work, the equation I'm going to work to solve for it. So again, we said that j equaled 27. Next question. I'm going to change colors here. So for number 5, if you remember, when we see fractions, you might say this is 48 r's. But that was because you first learned fractions, 1/2, 1/3, 2/4. But when you see it in the equation, we don't think of it as a fraction as much as we think of it as division. We think of it as 48 divided by r equals 12. And when you think of it that way, you can use your part-whole relationship understanding to know what operation to use to solve using 48 and 12. So r is being divided from an amount to get another amount, a smaller amount than 48, therefore a part, and it's not always, but since we're dealing with whole numbers, right, we're dealing with whole numbers here. So 48 is my whole. And I have a part of r, equal groups, right? This isn't exactly the same, but it would be equal groups. And so what would I do with 48 and 12 to figure out r? If I'm using multiplication or division, right? From my whole to my part, I'm going to be dividing. So I'm going to do 48 divided by 12, and I'm going to get my r. So 48 divided by 12 equals 4, and so therefore r equals 4. And again, plug it in and check. But it works every time when you know your part-whole relationships. 48 divided by 4 is 12. Number 6, we've got k equals 15 minus 9. I like how this one's already perfect. We want this just like this. The variable by itself and the numbers that we can solve part of the problem by itself. And 15 minus 9 is 6, so k equals 6. That one should have been like a breath of fresh air. Number 7, we have an amount times 1/5. Now, I want you to recognize that 1/5 is what we call a unit fraction. A unit fraction is when the numerator is a 1 and the denominator can be any number. When we're multiplying by a unit fraction, that's the same as dividing by the denominator. So I could rewrite this problem, understanding that principle that I can multiply the reciprocal when I'm dividing something, or I can divide the reciprocal when I'm multiplying something. Remember, the reciprocal is when we flip the numerator and the denominator, and 1/5 flipped would be 5 over 1, which of course is just 5. But then I also have to do the opposite operation. So x divided by 5 equals 60 is the same equation as x times 1/2, because I just flipped the fraction and did the opposite. So I really did keep change flip here to get my new problem. And this one's a lot easier because now I can view it as my part-whole relationship. X as my whole, and then I've got 5 and 60 as my parts. Now, obviously my model would look different. It'd be 5 groups of 60 or 60 groups of 5. But what would I do in order to find x? I would multiply 5 times 60 to get my whole. Since division, the big number, the whole number, you know what, there's lots of different examples here and I don't want to teach anything wrong. The whole comes first, all right? And so 5 times 60 would be my answer, and therefore x is going to equal 300. And again, plug it in and check. For number 8, it's just a simple plus question, an addition question, and we just happen to have decimals, but that shouldn't change kind of the process we work to do it. We have our parts over here and our whole over here, so 12.8 would be our big part of our model, and then m and 3.45 would be our parts. So what would I do to find my m using 12.8 and 3.45 is I would subtract them. I take my whole minus a part, I get a part. That's how subtraction works. And 12.8 minus 3.45, remember to keep your place values in line, means I have to add a 0 there. 8's going to become a 7, so that I can do 10 minus 5, which is going to give me the 3. And 12 minus 3 is 9, so I get m equals 9.35. And our last question, we have an exponent. So that would be, remember the base number is 1, the exponent is 5, and so the base number repeated 5 times, 1, 1, 1, 1, 1, and you're just repeatedly multiplying them. And this is the beauty of 1 to the power of anything. What is it going to equal? Well, it's going to equal 1. So a equals 1. And there you have your final answers for lesson 25. From Module 4 in Grade 6. Remember, take good notes. Rewatch this if you need to on any particular question. If you have any questions, then message me on Schoology or leave a comment or like if you're watching this on YouTube. All right, have a great day.